Welcome students, welcome to solid mechanics class. In the last video we have learned about the pure shearing stress and two mutual stresses are perpendicular to each other. Two stresses are perpendicular to each other. So in this lecture we will learn about the principal planes, principal stresses, and we will find out the expression for major principal stress and major principal strains and the shear stress. So let's start. Now let's talk about the principal plane and principal stresses. So the planes which passes through the point in such a manner that the resultant stresses across them is totally a normal stress is known as the principal planes, and the normal stresses across these planes are called the principal stress. Okay, again, the planes which passes through the point in such a manner that the resultant stresses across them is totally a normal stress is known as the principal planes, and the normal stresses across this plane are known as the principal stress. Okay, so let's see the how to derive this principal stress equation or the principal stress expressions. So let's uh, think a situation where the two-dimensional stress system is involved. That means where the direct stress and shear stress, the both are involved. So let's see. So this is a situation where LMN is a rectangular block, but we are cutting this rectangular block in a triangle section. So in a plane of LN at a angle theta, which is inclined with the LM side. That means this plane LN, this LN plane is inclined at an angle theta with this LM plane. Okay, and the shear stresses which are acted in LM side and MN side is tau xy. The direct stress is acted in LM and MN side is sigma x and sigma y, and the normal stress along this LN is sigma n, and the shear stress along this LN is tau. So this is a combination of the direct normal stress and the shear stress both. So let's see the what are the expression for this kind of case. So again, same as the previous, first we are going to resolve the all forces which are normal to LN plane. So resolving normal to LN, resolving normal to LN. So if we resolve this normal, we get sigma n into the area ln. Okay, ln into again the height is 1, so sigma n into ln, sigma n into ln, that is equals to tau xy, into lm sin theta, into lm sin theta plus sigma x into lm cos theta plus tau xy into mn cos theta plus sigma y into mn sin theta. So this thing comes from the geometry of the this figure. Okay, that's I have already described in the previous thing, in the for previous cases. Okay, I have already described this thing. So the value of sigma n is equals to tau xy lm by ln into sin theta plus sigma x into lm by ln cos theta plus tau xy mn by ln cos theta plus sigma y mn by ln sin theta. Okay, so this is the expression for sigma n. Now again the value of lm by ln or mn by ln. So let's see what are the values. That means from the trigonometry of the above figure we get, that is tau xy cos theta into sin theta. So lm by ln is cos theta. Okay, so cos theta into this sin theta, so that becomes sigma x. Lm by ln is cos theta, so cos theta into cos theta, that becomes cos square theta. Similarly, plus tau xy mn by ln is sin theta, so tau xy sin theta into this cos theta plus sigma y into this is sin theta mn by ln and into sin theta, so that becomes sin square theta. So the value of sigma n is equals to 2 tau xy sin theta cos theta plus sigma x cos square theta plus sigma y sin square theta. Sigma x cos square theta plus sigma y sin square theta. So by simplifying the equation of sigma n, let's see what we get. That is tau xy sin 2 theta plus sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. Okay, so this is the expression for of sigma n. This is the expression of sigma n. Okay, so by simplifying and we get this kind of expression. So now let's resolve the forces parallelly along the ln plane. So resolving parallel to ln, resolving forces parallel to ln. So let's see what we get. That is the parallel stress is the shear stress. So tau is the shear stress along the ln. Tau into ln force is equals to tau xy into mn sin theta plus sigma x into lm sin theta minus tau xy lm cos theta, minus sigma y into mn cos theta. Okay, so once again, so we can write tau equals to tau xy mn by ln tau xy mn by ln sin theta plus sigma x into lm by ln sin theta minus tau xy lm by ln cos theta minus sigma y mn by ln cos theta. Okay, so this is the expression. So from the geometry of the block, we can write tau equals to tau xy, this is mn by ln is sin theta, so we can write tau xy sin square theta plus this lm by ln is cos theta, this lm by ln is cos theta, so we can write sigma x into cos theta sin theta minus again this lm by ln is cos theta, so tau xy cos square theta minus this mn by ln is sin theta, so sigma y sin theta cos theta. Okay, so by simplifying we can write tau xy sin square theta minus cos square theta plus sigma x minus sigma y by 2 into sin 2 theta, or we can write tau equals to sigma x minus sigma y by 2 sin 2 theta, okay, minus tau xy cos 2 theta. This is sin square theta minus cos square theta, but the formula is cos square theta minus sin square theta, so that becomes minus cos 2 theta. So simply we can write minus tau xy cos 2 theta. Okay, so this is the expression of shear stress tau. Now in order to find out the maximum and minimum values of sigma n and tau, so let's see. So first of all, to get the maximum value of sigma n, we have to differentiate the sigma n expression with respect to theta. So d sigma n by d theta, we are going to differentiate the expression of sigma n with respect to theta. Let's see what we get. That is 2 tau xy cos 2 theta minus 2 sigma x minus sigma y, this is sigma y, by 2 into sin 2 theta. Okay, so by equating this by equating this expression to 0, so let's see what we get. We get sigma x minus sigma y by 2 into sin 2 theta is equals to tau xy cos 2 theta. So to find out the maximum value of sigma x, we have to equate this the derivative of sigma n with respect to d theta to 0. So we get this expression, or we can write tan 2 theta is equals to 2 tau xy by sigma x minus sigma y. So this is the maximum value for 2 theta, or it follows that for any particular system, the principal stresses may be calculated by considering the planes which carry the zero shearing stresses. For any particular system, the principal stresses may be calculated by considering the planes which carry zero shearing stresses. Now, to get the maximum value of tau, we have to differentiate the tau with respect to theta. So to get the maximum value of tau, we have to differentiate this tau with respect to theta. So the expression, the tau expression becomes, that is sigma x minus sigma y by 2 into 2 cos 2 theta plus tau xy sin 2 theta, 2 tau xy sin 2 theta. And now we have to equate this thing to 0, that is equals to 0. So let's see what we get. So that becomes sigma x minus sigma y into cos 2 theta, that is equals to minus 2 tau xy sin 2 theta. So by solving the previous equation, we get tan 2 theta equals to minus sigma x minus sigma y by 2 tau xy. Now let's resolve the forces normal to LM. Let resolve the forces normal to LM. Okay, so for the this comes from the previous figure, the triangle figure. Okay, so by resolving the forces normal to LM, we get the sigma x into LM plus tau xy into Mn is equals to sigma n into ln cos theta. This comes from the geometry, basic geometry. Okay, now we are going to resolve the forces normal to LM. Normal to LM. Okay, LM is the this is LM. Okay, we are going to resolve the forces normal to LM. Okay, and then we will resolve the forces parallel to LM. Okay, so let's see. So by dividing this, we get sigma x into LM by ln plus tau xy Mn by ln is equals to sigma n cos theta. Okay, this is sigma n cos theta. Now the value of Lm by ln is cos theta, and the value of Mn by ln is sin theta. So we can write sigma x cos theta plus tau xy sin theta is equals to sigma n cos theta. Okay, so we can write sigma x is equals to sigma x plus tau xy, sigma x plus tau xy into tan theta equals to sigma n. Sigma x plus tau xy tan theta is equals to sigma n. Okay, now we are going to resolve parallelly to LM. So resolving parallel to LM, we get sigma y into Mn plus tau xy into Lm is equals to sigma n into ln sin theta. Sigma n into ln sin theta. Okay, so now dividing both the sides by ln, we get sigma y into Mn by ln plus tau xy into Lm by ln equals to sigma n sin theta, that is equals to sigma n sin theta plus tau xy cos theta, sigma y sin theta, sigma y sin theta plus tau xy cos theta is equals to sigma n is equals to sigma n sin theta. So we can write sigma y plus tau xy cot theta equals to sigma n. Okay, now from this expression we can write the tau from the previous expression. That means from this expression, this is from this equation or from this expression, we know that tau xy tan theta is equals to sigma n minus n. So and from this expression we find that from this expression we find that tau xy cot theta is equals to sigma n minus sigma y. This is the expression number 2. Okay, so from these two equation, from 1 and 2, that means from tau xy tan theta is equals to sigma n minus sigma x, and from tau xy cot theta is equals to sigma n minus sigma y. From these two relations, so from tau xy tan theta equals to sigma n minus sigma x and tau xy cot theta equals to sigma n minus sigma y, from these two relation, let's see what we get. So from these two relation we can write tau xy square. Okay, by multiplying these two equation we can write tau xy square is equals to sigma n minus sigma x into sigma n minus sigma y. Okay, so we can write tau xy square is equals to sigma n square minus sigma x plus sigma y into sigma n plus sigma x sigma y. We can write this expression. So now it's a second order equation, quadratic equation. So by solving this equation for sigma n, we can find out the value of sigma n. Okay, by solving this equation for sigma n, we can find out the value of sigma n. Okay, so now by solving this second order equation, we can write the value of sigma n is equals to, we can write the sigma n or simply sigma is equals to sigma x plus sigma y by 2 plus minus half of root over half of root over sigma x plus sigma y square minus 4 into sigma x sigma y minus tau xy square. So this is the expression of sigma n, or by from this value we can write sigma equals to sigma x plus sigma y by 2 plus minus half of root over sigma x minus sigma y whole square plus 4 tau xy square. We can write by simplifying this above equation, by simplifying this equation, the above equation, we can write in this form. So from this equation we can comment that the major from this equation there is a concept that comes into picture, that is major principal stress and minor principal stress. So the major principal stress, the value of major principal stress, the value of major principal stress, that is sigma 1, is equals to sigma x plus sigma y by 2 plus half of root over sigma x minus sigma y square plus 4 tau xy square. This is the major principal stress value. Okay, now the minor principal stress, the minor principal stress, the minor principal stress value is sigma 2. Sigma 2 is nothing but sigma x plus sigma y by 2 minus half of root over sigma x minus sigma y plus 4 tau xy square. So this is the expression for sigma 2. This is the major principal stress and this one is the minor principal stress. Okay, so we can write the major and minor, this is the major and this is the minor principal stress expression into this fashion, that is sigma x plus sigma y by 2 plus root over sigma x minus sigma y by 2 plus tau xy square, or sigma x plus sigma y by 2 minus root over sigma x minus sigma y by 2 plus tau y square, tau xy square. So this is the expression for major and minor principal stresses. Now the maximum shear stress, the value of maximum shear stress, that is tau max, the value of tau max is sigma x minus, sorry, the value of a maximum shear stress is this one is sigma 1, the major principal stress minus the minor principal stress by 2. This is the maximum shear stress value, this is the maximum shear stress value, or we can write that is tan 2 theta is equals to 2 tau xy sigma x minus sigma y. Okay, so another thing, the most important that I want to comment, that the value of major principal stress and the minor principal stress is equals to sigma x plus sigma y. Okay, so in this lecture we have learned about the direct stresses, the pure shear stress, the direct stresses which are perpendicular to each other, and the principal stresses, and we have derived the different expression for major principal stress and minor principal stress, the maximum shear stress, etc. In the next lecture we will learn about the mode circle, how to draw the mode circle, and this kind of things. Okay, thank you.